Okay, so this will be for, it's not pre-calc, Algebra 2. We're skipping 8-3 and going to 8-4. Okay, and this is on graphing rational functions. Okay. Normally the rational functions, they will have a variable down in the denominator. But I do think it's important that you understand what the graph of an equation like this is. Okay? If you have x times y equals a number, okay, that will always graph a hyperbola. And you could solve for y, you could divide by x on both sides, but instead of doing that, to make a table of ordered pairs, just say what, and we're just going to do integers, two numbers that multiply together give you 12. 1 and 12, 2 and 6, 3 and 4. And then we could also go, we could go the negatives. You could go -1, -12, -2, -6, -3, -4. Okay? What that's going to graph, if you do 1 and 12, and you say 1 to the right and up 12, we'd be up here. If you said 12 to the right, okay, oh, we could go that one too. 12 and 1, 6 and 2, 3 and 4. Okay? So if we did 3 and then up 4, we'd be over here. If we did 4 and 3, we'd be over here. 2 and 6, we'd be up here. 6 and 2. So what you end up with, okay, is, and then if you do the negatives, you would be graphing in this one. So anytime you have x times y equals a number, your graph is always going to be a hyperbola, and we graphed those in the last chapter. Okay, in the last chapter, we graphed, and they were either opening. Remember, in the last chapter, we graphed where we did a little box. Remember that? And then we did the asymptotes coming through the guides, and then it was either opening on the x, something like that, or it opened on the y. But on this one, it's the center point is like at 0, 0. And this is a little bit different equation. This is a hyperbola. The other hyperbola equation was like x squared over a squared minus y squared over b squared equals 1. Remember that? Okay, so that's one thing in this section, and I think that would be a good ACT type question. Okay, anytime you have x times y equals a number, it's always going to be a hyperbola. Okay. Okay, then they define a rational function. A rational function has an equation in the form f of x equals q of x divided by, or sorry, I said that wrong. That's p of x, sorry. P of x divided by q of x, where p of x and q of x are polynomial functions. And q of x cannot equal 0 because you can't divide by 0, so you have to put that qualification in. Okay? Okay, so you just can't divide by 0. Okay, now examples. They will say determine the equations of any vertical asymptotes. Make sure you spell that right. Determine the equations of any vertical asymptotes and the values of x for any holes or open circles in the graph. And when they say any holes or open circles, that's where the rational function is undefined. Okay, you can't have division by 0. Okay, so we're going to look at an example. So you have, and they can use either f of x or they can say y. Up in the numerator is x squared minus 4, and it's all over x squared plus 5x plus 6. And I'm purposely putting those parentheses around the quantities because you're going to need those parentheses. Put them around the top and the bottom. You're going to need those when you graph it. Okay, so when you put it in on the calculator. First, we can factor that top part. That is the difference of two squares. That'll factor into x minus 2, x plus 2, 1 plus sign, 1 minus sign. And the bottom we can factor, there's nothing in common, plus 3, plus 2, yep, okay. Now, here's where you actually stop, and the vertical, when it asks for vertical asymptotes, the vertical asymptotes and the open circles have to come from the denominator. So you look at the denominator and say x cannot equal, what's going to make that denominator 0? What's going to make this 0? Negative 3, negative 3. Yeah, yeah. And what's going to make this 0? Okay, so those are the two things. X cannot be negative 3 and x cannot be negative 2. Those are either vertical asymptotes or open circles. Okay? And at this point you can't tell which. Okay? Until you graph it. When we graph these, we are going to graph them on the graphing calculator. We are not doing them by hand. We're doing them on the graphing calculator. Okay? So, we are going to stop and put this in on the calculator. Keep going now. Okay, so I want parentheses. And I'm going to put it in the, I'm actually going to put in the original. Put in x squared minus 4, parentheses, divided by, parentheses. Yeah, then we want x squared plus 5x plus 6, close the parentheses. Okay, now I'm going to do zoom 6, zoom standard, zoom 6, so it's negative 10 to 10, negative 10 to 10. Okay, and I get a graph. Okay, now on mine, and I wish Texas Instruments could get this to graph right. Okay, I show a vertical line that is not part of the graph. That is a vertical asymptote. Okay, and then the graph would look like this, and then it does not go through the origin, goes through a little bit less, and then it comes up, goes through something like this. Okay, you agree with something like that?
Yeah.
Okay, how many of you do not show that vertical line on your calculator? Okay, okay, because of the newer calculators, the older calculators will always show you the vertical asymptotes. To get them to show, to me, it's just backwards of what you want. On your calculator, do second function format. I think it's above the zoom key. Second function format on that top row. And then go down, it should say asymptotes on or off. And you actually have to turn them off to get them to show up. You turn them to off to get them to show up. Okay, so let me stop there. Okay, so on the new calculators, if you have your own, you got to go second function format, and you actually turn the asymptotes off to get them to show up. To me, that's backwards, but that's just the way it is. Okay, now look at what we said up here. We said x cannot be negative 3. Where is this asymptote? Negative 3. The vertical asymptotes and the open circles occur from the denominator. Okay, so we know this, and anytime you label a vertical asymptote, it has to be vertical line is always x equals a number. This is a vertical asymptote, and we're going to abbreviate it VA. What I will not take, you know Lady Elliot, I will not take vertical asymptote equals 3. No, a vertical line is x equals negative 3. That's the vertical asymptote. So don't write VA equals negative 3. It has to be x equals negative 3. That means this is not showing up as a vertical asymptote, so that means there is an open circle at x equals negative 2. Somewhere down here, there is an open circle. So to find it on your calculator, go back to do second function calculate. Do second function calculate and do value number 1. And then it comes up x equals, and you type in negative 2. Second function calculates right above the trace key. Here. Right above the trace key. Do second function calculate and do value at x equals negative 2. Sorry, negative 2. Okay, and you get an open circle. If you want to try second function calculate value at x equals negative 1.99. Okay.
So where do you see the open circle?
Okay. If you look at negative 1.99, you get about negative 3.95, right?
We don't.
Okay, go one more. It's not going to show up. You have to be smarter than the calculator. Do second function calculate value at x equals negative 2. Look, is there a y value showing? No, that's your open circle. Okay? So, we said negative 1.99 was, so this was like, negative 1.99. So somewhere in here, there is an open circle. Okay? So this is the open circle. The vertical asymptote and the open circle. Any vertical asymptotes, any open circles. Let's put that down. Any vertical asymptotes or open circles come from the denominator. Okay? Okay with that? So we're going to graph it. Okay? Okay, now let's look at another example. Say they ask you to graph f of x equals x divided by x plus 1. What values must you exclude from the domain? X cannot be negative 1. X cannot equal negative 1. So we're going to graph it, and then we're going to figure out, is that an open circle at negative 1, or is that a vertical asymptote at negative 1? It has to be one or the other. Okay, and you need to make sure you put parentheses around this. Okay, so clear out that equation, put in the new one. So we want x divided by parentheses x plus 1. The author is not going to tell you to put in the parentheses, you just have to know. And then we're going to do zoom. We're going to do zoom 6. Okay, now on mine it kind of shows as a spike. Okay, so if I do a better window, I'm going to do zoom 4, zoom decimal. Now on zoom decimal it doesn't show, but it is a vertical asymptote. Or I can change the window. Let's go negative 5 to 5, scale 1, and let's go negative 4 to 4. See if it shows up. Nope. Oh, yeah, it does. Okay, so at x equals negative 1, that is an asymptote. Okay, and we've got part of the graph here, and this one. If you want to know, does it go through the origin? Do second function calculate value at x equals 0. Does it go through? Yes. 0, 0. So it goes through 0, 0, and goes something like this. And I put arrows. You should put arrows. It's going to continue on. Arrows at both ends. Okay, and it will approach the asymptote. It should not touch it. Okay. So our vertical asymptotes, if they ask what the vertical asymptote is, x equals -1 is the vertical asymptote. Is there an open circle? No. No. Okay. You would have to have another quantity down there for. Yeah, we know this one is definitely an asymptote because it shows up as an asymptote. Okay, we've done vertical asymptotes, and open circles come from the denominator in rational functions. Okay, now what about the numerator? Okay, the numerator is going to give you horizontal asymptotes. Okay, so this is the shortcut method. The shortcut for horizontal asymptotes. For rational functions. And if you go on into pre-calc and calc, I always call this my calc shortcut. So you're actually getting a calc shortcut. Okay, if you have f of x equals, up in the numerator is p of x, down in the denominator is q of x. Okay, there are 3 parts to this shortcut. I'm going to give you the notes, and then I'll explain in the example. Number 1, if the degree of p of x, if the degree of the numerator, and when we're talking degree, we're talking the exponent, okay? If the degree of the numerator is less than the degree of q of x, then y equals 0. Y equals a number is going to graph a horizontal line. In this case, y equals 0 is a horizontal asymptote. So, like if we had the degrees less on top. So say the degree on top was x to the 3rd, and the degree on the bottom was x to the 5th. I automatically know y equals 0 is a horizontal asymptote. The degree is less on top. Okay. Second one, if, and I'm going to abbreviate this a little bit, if the degree of p of x equals the degree of q of x, then y equals k is a horizontal asymptote. I didn't spell that right. There's me. Spell it wrong. There's me. Look at the P. Asymptote. Y equals K is a horizontal asymptote where K is the ratio of the leading coefficients. Okay, and the third one, if the degree of the numerator is bigger, greater than the degree of the denominator, q of x. If the degree of p of x is greater than the degree of q of x, then there is no horizontal asymptote. I will tell you down the road, this is one that we deal with down the road in calc. It won't be, everybody look up here, it won't be a horizontal asymptote. It's going to be an asymptote that looks like this or like this. It'll be like a parabola or a cubic asymptote. Okay, so that we take it a step higher in calc. Okay. Okay, so let's go back for a minute. It says if the degrees, let's do this one first. If the degrees are the same, y equals k is a horizontal asymptote. Go back up to this first problem. Look at the degree. The degrees are both, the exponents are both equal, right? So there is a horizontal asymptote, y equals k, where k is the ratio of the leading coefficients. So 1 divided by 1? 1. So the horizontal asymptote is y equals k, y equals 1. What do you guess this horizontal line is that these are approaching? 1. That graph on both ends is getting closer and closer to 1. Y equals 1. So there is a horizontal asymptote. Okay? Go to the next one. The degrees are both 1. The k is the ratio of the leading coefficients. 1 over 1. So what do you guess this line is? Y equals 1. So this one is y equals 1. Both parts of that graph get closer and closer to 1. Okay? If I did one like this, say I did I'm going to just make up one. Say I gave you f of x equals, up in the numerator, 4x plus 5, and down in the denominator, 6x minus 7. Okay, the degrees are the same. Okay, so it's the ratio of the leading coefficients, 4 over 6. So y equals 4/6, or y equals 2/3. So your horizontal line is going to be at y equals 2/3 going across. Okay. If you go back up to number 1. If the degree is less on top, let's say I make up one and I do f of x equals, let's say I had 3x squared minus 9 over 7x to the 4th plus 5. The degree is less on top, so the asymptote is
0.
Y equals 0 is your horizontal asymptote. If the degree is bigger on top, we're just going to say in Algebra 2, no horizontal, and that's true, it is not a horizontal asymptote. So if you had one like this, say I gave you 5x to the 3rd plus 4 over 3x to the 2nd minus 7x plus 2. Okay, the degree is bigger on top, so you say no horizontal asymptote. And that's basically the calc shortcut. If the degrees are the same, it's the ratio of the leading coefficients. If the degree is less on top, it's y equals 0. For you people, you really only have two options. The rest of them don't exist. And you'll be able to tell graphically. You'll be able to tell by looking at your picture, is there a horizontal asymptote? Okay. And there won't be. Okay. Okay. Make sure you have graph paper for tomorrow's assignment. Okay. There's 6 problems. Okay. I'll give you time to work on that. Yeah, hang on a second. Gotta get my pen back.